All right. We're going to continue our discussion of Chapter 6 today. So in Chapter 6, we've been talking about these other identities. Stop talking, please. In the previous lesson, we talked about the sum and difference identities, as well as the double angle identities. Today, we're going to talk about the power reducing identities and the half angle identities. So recall from last time, we had given these, we had ended by talking about these double angle identities, correct? What I'd like to highlight here is, say, this part right here. Because if I rearrange this by getting the cosine squared u by itself, I'd add 1 over and divide by 2. And that's going to become what will be called a power reducing identity. I can do this then for any of these. And the result is going to be these 3 power reducing, what we'll call the power reducing identities. So just like before, we can use these to do kind of 2 sorts of problems. We can use them to do like these find the exact value of the trig function problems. So if I wanted to do cosine of squared of 60 degrees, I can use my power reducing identity above to write this as 1 plus cosine of 2 times 60 degrees over 2. Well, 2 times 60 is 120. And if I go to my unit circle, the cosine of 120 is, well, it's negative because it's in quadrant 2, correct? And that's actually negative 1/2. That's a unit circle value. And then to just simplify my complex fraction, I'll multiply the top and bottom by 2. So I get, 1/4. If I wanted to do sine squared of 3 pi over 8, I'm just going to use the power reducing identity for sine squared. So it's going to be 1 minus cosine of 2 times 3 pi over 8 all over 2. 2 times 3 pi over 8 is 3 pi over 4. Again, that's going to be negative because it's in the second quadrant. We're doing cosine, and the is actually negative root 2 over 2. And once again, to get the fractions out of my big fraction, I'll multiply the top and bottom by 2 over 2. It's going to give me 2 plus root 2 over 4. Now the last one, we have cotangent squared of negative 165 degrees. Notice that we don't have any cotangent power reducing identity. What do you suppose we're going to do? Flip the tangent one. Yeah, I'm just going to use the reciprocal of the tangent one. So I'm going to write it this way for starters. So I'll write it as a reciprocal. And then I can use my tangent power reducing model. And now I'm going to do my flip. So I'm going to use that negative exponent to do my flip. And 2 times negative 165 is negative 310. And my odd-even identity says cosine of a negative angle is the same as cosine of the positive angle. And now it's just calculator time. Cosine of 3, how would I get 310, guys? Is anybody confused by that? Try again, Mr. Kulik. About 330. Arithmetic is hard sometimes. If you see it earlier, why didn't you say anything? Oh, 10 minutes? Oh my. So what do we got here? We got square root 3 over 2 is what cosine of 330 is. That's in the 4th quadrant, so we know it's positive. And then just like before, to get rid of the fractions inside of fractions, we'll multiply top and bottom by 2. Ugh, what's wrong with this? Yeah, we have a radical in the denominator. Oh, blast it all. And it's the hard situation where the radical is being added or subtracted to something. Ugh, who remembers what we have to do to get rid of that? Multiply by the conjugate. Great. What would the conjugate be in this situation?
Isn't it 2 plus?
Yeah, it's the same thing with a different sign in the middle. So like if you have A minus B, its conjugate is A plus B. Right? So the bottom is easy. That's just a difference of 2 squares. The top, though, we have to FOIL this out. I'll write that as 2 squared. So let's see, 4 minus 3 is 1. I have 4 plus 3, that's 7, plus 4 square roots 3, or just 7 plus 4 square root 3. Neato! So again, we can use these identities to find the exact value of angles that we couldn't ordinarily do anything with on the unit circle, correct? Couldn't do a thing prior to this with cotangent squared of negative 165. Not a thing you could do with that without these identities. Yeah, I mean, it's all in the OneNote though, dudes. Well, I understand it takes a long time to sync, but it's like, it's there eventually, right? Don't have to write it down all in real time all the time, do we? I mean, you can, I guess, if you want to, but we're just grinding here, you know? All right. And then the other thing, stop talking, please. Try it again. Let's stop talking, please. The other thing that we'll often do with these identities is use them to prove things. So let's take, for example, this guy. What are you complaining about?
No, it's fine.
You've just been talking to your other friend for like last minute.
No.
If you were that busy writing it down, you would have been writing it down.
No, I'm just the one that was really
Oh.
It's okay. It's
Okay.
okay.
All right. So when I look at this, considering it says use power reducing identities, I'm going to work on the left-hand side. Now, I don't have a power reducing identity for sine cubed, but I can rewrite sine cubed as sine squared times sine. Cool with that? Which is awesome because I see that, hey, now I have a factor of sine, which I'm supposed to have in my answer anyways. So everything else that has to happen is just going to happen to that sine squared. So I'll go ahead and use my power reducing identity for sine squared, which is 1 minus cosine 2x over 2 times sine x. So when I think about this, this is really three things multiplied together, right? I have the 1/2, and then I have the 1 minus cos x, and then I have the sine x. And since those are just three things multiplied together, I can multiply them together in any order I want. For example, I could do 1/2 times sine x times 1 minus cosine 2x, which is exactly what I wanted to end at. And I'm done. Like one identity. That's all I needed to use there. Cool beans, Daddy-O. It's the identity. Sine squared is 1 minus cosine 2x over 2. Just like literally wrote down the identity. Right? All right. Pretty similar kind of problem. It's very, sounds very much like a simplifying problem here. It just says rewrite cosine to the 4th with no powers greater than 1 using the power reducing identities. Okay. Well, cosine to the 4th, I don't have a power reducing identity for 4th, but I do have it for squareds. So I'll just rewrite cosine to the 4th as cosine squared times cosine squared. I have power reducing identities for each of these. Oops, yeah. Everybody happy there? I'll multiply those two fractions together. When I multiply the tops, I have to FOIL that out. I'm going to do that foiling in my head if that's okay with you guys. Oops, that shouldn't be 4, that should be 8. Oh, what am I doing? Jeepers creepers, Kulik.
I don't care.
How did you do this? How are you being so dumb? Stop being dumb. There we go. All right, sorry about that. Had an extra 2 floating around in there. I don't know why I did that. Okay, am I done? No, right? What's the problem?
There's still, yeah, that.
I still have a power greater than 1. What am I going to do there?
I don't know.
Another power reducing. Please stop talking. That doesn't mean continue your conversation quieter. It doesn't mean continue your conversation even quieter after laughing at what I still hearing you. Everybody's okay there? Last thing I'm going to do is just multiply the top and bottom by 2 to get rid of the fractions inside of the fractions. So it's going to give me 2 plus 4 cosine 2x plus 1 plus cosine 4x all over 8. And I suppose I could add that 2 and the 1 together. Those are like terms. And that I would say is my final answer. Okay. Yes.
Could you hypothetically stop at the part where it's like the 1 plus 2 plus whatever, it's like all over 4 before you multiply 2 over 2? Like, there's no power over 1.
I mean, yeah, I guess so, but like, who wants to leave it when you have like easy simplification left to do?
No, 100%.
But yes, technically you've met the criteria of the directions. Logan. Nope. Nolan. Logan. How did I get to Logan? I don't know.
Can I set the question, but didn't ask you power reducing? You just throw cosine times cosine times cosine.
Yeah, I mean, like you could be that dumb. Yes, that would be the obvious thing to do if it was like did not ask you to use a specific kind of identity to do this. Yeah. All right. Half angle identities. So what we're going to do here, we're going to start with one of our power reducing identities. So hypothetically, maybe we'll start with sine squared. And then I'm going to say let x be something like theta over 2. So that's like a half angle, right? So those 2's can just kind of cancel each other out. And I have this. And then we're going to square root both sides. Again, since I'm squaring both sides of an equation, I get a plus or minus. So that's the half angle identity for sine. I could repeat this similar process to get the half angle identities for the other guys. But rather than doing that, let's just drop them in here. Notice this last half angle identity for tangent. How many options do you have there to choose from? 3. Does it matter which one you use? Not often, although being judicious about which one you choose can make a problem a little more straightforward than maybe another one. So they do have like pros and cons, but they all work. And again, like we've done, we're going to start by doing some examples of ways we can use this to find exact values. So if I want to do cosine of 75 degrees, I'm going to rewrite 75 degrees as a half angle. So 75 is half of what angle? 150, which happens to be a unit circle angle. Yay! Okay, so I have plus or minus square root of 1 plus cosine of 150 over 2. Everybody feel okay there? Now I'm going to make my decision right now about whether I want plus or minus. Cosine of 75 is in quadrant 1. Cosine should be positive in quadrant 1, so I'm going to drop the minus off the plus or minus. Everybody's good there? Okay, let's continue on now. So cosine of 150, 150 is in the second quadrant, so that's going to be negative root 3 over 2 over 2, all under a square root. Now I want to get rid of the fractions inside of my fraction. What do I have to multiply the top and bottom to do that? No. Square root of 2 over square root of 2. Why do I need the square root around that stuff? Because you need to multiply it into a square root, right? If you got to multiply square roots together, the stuff has to be both under the square roots. So we have 2 minus square root 3 over 4. Everybody's good there? Notice the square root of 4 in the denominator. So I'll just do that and write the square root sign only over the numerator. That looks pretty good to me. So worth pointing out and reminding you guys that all these are checkable on your calculator. So worth doing that. So if I'm in degree mode, and I do cosine of 75, I get that number. And if I type in my answer, I should get the same decimal, right? I'd say at this point I'm pretty darn convinced I did that right. right? All of these find the exact value ones are checkable on your calculator. You guys get what I'm saying?
Can you just scroll up a little bit? I just wanted to see the sign of half angle. Okay, I just want to make sure. Thank you.
No problem, dude.
Wait, these should be the same.
I did cosine of 75, and I typed in my answer. I get the same decimal.
Oh, yeah.
Right? That's all I'm saying. All of them are checkable on your calculator, though. Now, is Mr. Kulik looking for a decimal here?
No.
No, because he says exact value. So whoop-de-dee-doo that you can type that in your calculator. Mr. Kulik's interested in all that work that I did beforehand. All right, sine of 9 pi over 8. How do I do sine of 9, or sine 9 pi over 8 is half of what angle? Okay, 18 pi over 8, which it just reduces down to 9 pi over 4. That's the way I would write it. So I'll apply my half angle formula. And here, I'm going to decide whether I want the plus or minus. What quadrant is 9 pi over 8 in? Yep, Q3. In Q3, sign is negative. So I'm going to just take the negative sign. Everybody feel good there? Cosine of 9 pi over 4. 9 pi over 4 isn't on the unit circle, is it? But it's coterminal to what angle on the unit circle? Pi over 4. Yeah, if I just subtract 2 pi from that. And when I go to my unit circle, cosine of pi over 4 is root 2 over 2. And then I do my same multiply by root 2 over root 2. And that gives me 2 minus root 2 over 4. Or just square root 2 minus root 2 over 2. Oh yeah, I forgot my negative sign. Thank you. Yeah, where did that disappear at? Right here.
I'm just confused how you went from 9 pi over 8 to the 9 pi over 4 over 2.
Half of 9 pi over 4 is 9 pi over 8. Well, what's half of a half? A fourth, right? What's half of a fourth? So half of 9 pi over 4 is 9 pi over 8, right?
And then how did you get from 9 pi over 4 to 5?
Because they're coterminal. Right? 9 pi over 4 is 2 1/4 pi. So just the 2 pi can just whoop, get out of here. Okay, cotangent of negative 105. Well, negative 105 is half of what angle? Negative 210. So this is going to be, I don't have a half angle identity for cotangent. So I'm just going to use the tangent one and do the reciprocal of it. Everybody happy with that? Okay. So comes down to it. Which one of these looks the most appealing? I have three choices. Anybody, any interest with the first one? No, that looks terrible, doesn't it? Looks like a terrible, terrible choice. So it's between the second one and the third one. Which there is a better, best choice here. Third one, great. Why? When I make the reciprocal, I'm going to have just a sign in the denominator, correct? That means no rationalizing the denominator later on, or if I have to, it's going to be like easy, not like a pain in the tuchus where I have to multiply by a conjugate. So that's my justification. All right. So I'm going to have here sine of negative 210 over 1 plus cosine of negative 210 to the negative 1. So let's go ahead and do our reciprocal then. And I'm going to find the coterminal of the negative 210 because that's not a unit circle angle, right? So I'm just going to add 360 to that and make it 150. So I dropped that negative 1 exponent because I did the reciprocal. And I did coterminal of 210 as 150. Cosine of 150 is negative root 3 over 2. Sine of 150 is 1/2. Multiply the top and bottom by 2 over 2, and I get 2 minus root 3.
I don't know, maybe I'm missing something, but when you wrote like tan negative 210 divided by 2 or over 2, where did the over 2 go next? Or just cancel out?
It goes away because the half angle.
Oh.
You just
The
take,
identity?
yeah, the identity, right? That's the power of the identity, is it gets it to a unit circle angle. Because negative 210 over 2 is not a unit circle angle.
Yeah.
But 210 is.
What gives you the root for like cosine, sine, not?
Well, one of the tangent ones has a root in it.
How come we didn't do this?
I picked the one that I wanted to do, which looked like the easiest one computationally. So you had the choice. There's 3 that are equivalent. They all would give you the same answer. And just like which one looks the easiest. And because Mr. Kulik's experienced, he can see right away which one was going to be the easiest. I added 100 or 360 degrees to negative 210 to get a coterminal angle that would be on the unit circle. Sophia. Yeah, it's 2 minus root 3. Okay. Let's do a proof example. So it says, prove the following identity. Which side to you looks like the better side to start with? I would agree. So let's start with the left-hand side. what identity would you presume to use first? You could either do a half angle identity here, or you could do like a power reducing identity there. It doesn't really matter which one. I would do the half angle though, if you asked me. Which one would you do, Mr. Kulik? So if I do that, I'm going to get the square root, or plus or minus the square root of 1 plus cosine x over 2. But you see this here? Squared. Is everybody okay with that? You get where that squared is coming from? The half angle identity doesn't have a squared on it. Well, that squared is actually quite nice. What's that squared going to do for me? And the plus or minus, right? Because if I square something, it has to be positive afterwards. All right, let's rock and roll. I love it. If I ever see a squared paired with a half angle, I feel pretty darn good about what's going on. What else do you notice now? Yeah, I love it. Feels like we're making some nice progress. Look at all the stuff that's canceling out here. Okay? And this is what I would do next. I'd rewrite cosine as 1 over secant. Now, we don't do that very often. Why am I choosing to use my reciprocal identity to do that? Well, look at where I'm trying to get to. My answer has all secants in it. So I could turn the secant into a cosine, distribute through, but then I'm just going to be turning my answers back into secants. Like, why would I go from everything into cosines and then turn it back all into secants when I just go straight to secants and there's, just like saves me a step. And there's that. What do you guys think? It's all right? Now I have a question for you. Do you want to do 6-4 now, or do you want to do 6-4 on Thursday? If we do 6-4 now, you know what we do on Thursday?
Review.
Nothing.
No, I'd actually rather do it on Thursday.
Wait, let me ponder this for a minute.
Yeah,
How long is 6 for?
20 minutes.
Guys, just knock it out. Just knock it out.
It's only 20 minutes.
We got
Why not just do it Thursday?
Yeah, I feel like we should tired.
You guys are all crazy. I don't know why you'd want to wait.
But if we do, wait, I have a question. If we did 6.4 today, wouldn't the 6.4 work we do this Sunday?
It was going to be due this Sunday anyways.
Yeah, even if on Thursday.
Yeah.
Wait, but normally it's not.
Normally, but we don't have any more weeks left.
I'm kind of mentally exhausted.
Oh, on Thursday our whole class is. Yeah. It's technically the same thing. Let's just do it next class.
Yeah, that's next class.
Yeah, next class.
Next class, I'm not brain dead.
Alright, well.
All right, well, let's talk about the final then. We can do that. No, let's not. Everybody's here right now. Why would I take a chance on people being absent? All right, so your final, I put in the equation sheet that I'm going to hand you for the final. So the equation sheet for the final is right here. So as you're reviewing, I would have this out so you're like familiar with what is on it and what you have to like memorize and what you'd have to look up. Let's do this page. Ooh, semester. All right. Let's see. Exam format. What chapters are we covering?
1 through 6.
Okay. 3 questions per chapter. Okay. Everybody's okay with that? All the questions are equally weighted?
Can you get partial credit?
Yes, of course. Shh.
Not 300.
So even if a question has multiple parts, shh, zip it. Question has multiple parts, it still counts as one question. All the parts will sum to 5 still. It's still skippable. If it has parts A, B, and C, that's one skip for all parts A, B, C. Okay? You would not like that. I would find every dumb mistake that you could make, and those would be multiple choice answers, just like on the ACT. And then there's no partial credit possibility.
Yeah, true.
Well, what if one of the answers is like none of the above as one of the 4
Oh, that's
on every one?
Oh, I hate that. I hate that's so. I hate none of the. Yeah, never mind. I take that.
You know why I put that on there if I'm writing a multiple choice test as a math teacher? If I screw up the question, then I'm covered. It's still answerable. Like if I make a mistake and they're like, oh yeah, I did something dumb, and it's just like, yeah, you can still do it because it's still, the answer's still there. All right, we're not doing that though.
Yeah. I didn't think it was gonna happen.
No, why don't you guys just hang out?
All the exam questions will be a version of an old test question. What does that mean?
Like the same question from the test, but like with different numbers.
Yeah, same question, different numbers.
Do you think if we just studied our test, we could get
That's all I would do. You can make a half sheet of notes to use on the exam.
Oh my god, it's like half of the
This is so nice.
how does he half of the post? Like literally half.
You can use anything that is the same size or smaller as a half sheet of computer paper. Okay? So I'll just have a half sheet that I'll cut, and I'll just measure your sheet with it and let you know if it's too big or too small. Well, if it's too small, I don't care, right?
One side of a half sheet.
Why not just one sheet? Because then I don't have to turn it over to make sure you only wrote on one side. If it's a half sheet and I can write on both sides, I don't have to look at the other side. It doesn't matter. You can write on it, that's fine. If you don't, that's fine. It saves me time. No. I will not do that. But Let's see, what else can I tell you? Okay, so to study, what should you study? The old tests, right? What should you put on your sheet of notes?
Everything.
The hardest stuff from the test that you did. Whatever you had the hardest time with, put it how to do that problem or problems, right? You can put whatever you want on your stupid half sheet. I'm not going to look at it. I'm not going to read it. Well, should you waste putting formulas on there that are on the equation sheet that I'm going to hand you? No, don't do that. I would stick to like examples and like instructions to yourself about like how to do things, or like formulas that are not on the sheet, right? Does everybody feel okay about this exam format?
Yes.
I will, yes. I don't think I have everybody's taken yet, but as soon as I do, you know what, heck with it, I just give it to you today. It doesn't matter. I don't even know for sure if that other person's, if those other people are going to take it or if they've taken it or where they're at with it. It just, we can do that. Okay. Last thing I need to do. What else do I still need to do? You guys should all have your chapter tests from 1 through 5, correct?
Yeah.
What don't you have? 6. What do you think I'm going to put in the content library in a minute? A chapter 6 test. So you can have something that like, okay, this is what chapter 6 test would have looked like, so that you can have something to study from. And
Do you normally get through chapter 6?
it's usually kind of this, where it's either we've just barely squeezed it in, or it's we have enough time to do everything but test. So this is pretty normal, keeping in mind that we've only had like this block scheduled for like 2 years or 3 years. I'm not going to make a review pack.